So let's see that whether it's PDF and compute its expectation and variance and all other stuff actually. ठीक है. Okay, so for that what I need to do, I need to compute, say, from minus infinity to infinity the integral of fx of x dx, and I need to show that this is equal to 1 actually. So for now I don't know that what is this value, so let's call it I, and I want to show that this I is basically equal to 1. Okay? So let's show this. So what if I, minus infinity to infinity e to the minus x. So I'm going into the details of these tedious calculations because it's important to learn how to do the computations with the Gaussian integral, because at many situations, काफी सारी situations ऐसी आएंगी कि where you have to do such computations actually. ठीक है. So x minus mu chi square by 2 sigma square, ठीक है, and let's call it dx, and everything divided by square root of 2 pi sigma. So this is what is the integral, and I want to solve this integral. So how can I solve this integral? Let's solve it. So let's not give this guy a name. Okay, so I want to show that this is equal to 1. Okay, so it would be this. I am आगे चल के किसी और इंटीग्रल को नाम देता हूँ. So what we need to do, maybe we can simplify this integral a little bit, and let's introduce, for example, a random quantity y, and let's call this quantity as x minus mu by sigma. Okay. It's going to radically simplify this expression. So integral go. So what would be dy? Dy is going to be, dy by dx is going to be 1 minus 0 over sigma. So it's going to be dx by sigma. Okay, so dx by sigma is really what is called dy. What would be the impact on the limit? So if you're going to substitute, or if you take as this x goes to minus infinity, so you have minus infinity minus mu, so the y would go to minus infinity. In other words, as x goes to negative infinity, y would also go to negative infinity. And as x goes to positive infinity, y goes to also positive infinity. Okay. And see what we get. So we're going to get something interesting. So you have minus infinity to infinity. Let's put, say, square root of 2 pi here. And we're going to have x minus mu over sigma square. So I can put them together. I can say x minus mu over sigma whole square divided by 2. So this is going to be minus y square 2 upon 2 actually. ठीक है. So अगर मैं इसको इस sigma square को इसके अंदर रख दूँ और मैं कहूँ x minus mu over sigma का square divided by 2 है, so it's going to be e to the minus y square by 2. So 1 over square root by 2 is here. Dx upon sigma is my dy, so I can put this as dy. Okay. Let's call this integral star actually. And I want to compute this integral. This integral is called Gaussian integral. Let's give this integral a name. Minus infinity to infinity minus e to y square by 2 and dy. Now I want to find the value of I and then substitute it here so that I can see that whether I get 1 or not. So the trick to solve this integral is to consider the square of it. In other words, multiply I by I. So let me put I, which is minus infinity to infinity, e to the minus y square by 2 dy times minus infinity to infinity. Since this is a definite integral, क्योंकि definite integral है, definite integrals में variable matter नहीं करता, whether it is y or x doesn't matter. So जो पहला integral है square में I'm putting in the terms of the y, और दूसरा integral I'm putting it in the terms of e to the x square by 2 and dx. ठीक है? Okay. Now this number is a constant actually. ये पूरे का पूरा number जो है, this is a constant. So if I wish, I can take this constant c, जिसे मैं c कह रहा हूँ, and I can put it here inside. यानी ये जो constant है मैं यहाँ भी रख सकता हूँ. This is not going to change anything because this is the constant. Independent of the y, इसमें y कहीं भी involve नहीं हो रही. ठीक है. Trouble तब होता कि जब इसमें y involve होती. So I can take this whole thing and put it here. So if I'll put it here, I'm gonna get minus infinity to infinity. ठीक है. I'm gonna get e to the minus x square by 2. ठीक है. And say dx minus infinity to infinity e to the minus y square by 2 and dy. So I just substituted it here. Now this integral is with respect to x. So this y thing is like a constant here. So if I wish, I can pull this integral, यानी ये जो y का e to the y है, क्योंकि ये y के terms में number है और ये integral x के terms में है, तो अगर मैं चाहूँ तो इसे I can substitute it here. So I can take this number and substitute it here. यानी इस integral के अंदर ला सकता हूँ. So I'm gonna get what? Minus infinity to infinity. Minus infinity to infinity, e to the minus y square multiplied by e to the minus x square by 2, so I can write it as e to the minus x square plus y square by 2 dx dy. ठीक है? This trick is an important trick to realize. Okay, so this is equal to what you call I square. अब क्या करें? So I want to solve this integral. So from your multivariable course, you might know that कि जहाँ भी ये x square plus y square की term की तरह आ जाए, that's a, you can solve such integrals by using the polar coordinates. ठीक है? So अगर इन integrals को मैं इस जगह में x की जगह r cos theta रखूँ और y की जगह r sin theta रख लूँ, ठीक है? r cos theta and y to be r sin theta, ठीक है? Then I know that my x square plus y square is equal to what do you call r square cos square theta plus r square sin square theta, ठीक है? So it's going to be r square simply. So this is going to be x square plus y square equal to r square. Okay. Then we know in polar coordinates dx dy can be turned into dr d theta, but you need to multiply it with the Jacobian of the polar coordinates actually. और जो Jacobian होता है polar coordinates का, it's really r actually. So you can write this as r dr d theta dr doesn't matter. ठीक है? अब लिमिट्स की तरफ आते हैं. अगर आप लिमिट्स गौर करें इस वक्त क्या है वो it's really this everything, because x can go from minus, y can go from minus infinity to infinity, x can go from minus, so it's everything. So what does polar coordinates do? So the polar coordinates do this. So it says that okay, take a circle. अब मुझे इस सर्कल की मदद से यही पूरा एरिया कवर करना है. So how can I cover it? So I want to take this circle and I want to cover this entire, what do you call, area. So let's say that this is R actually, the radius is R. So if I take my R and I say that okay, R goes to infinity, यानी ये R जो है ये increase हो रहा है, तो जैसे जैसे ये R increase होता जाएगा, I can cover the entire, what do you call, this two-dimensional plane by my circle actually. Okay. So in other words, R can be anything from 0 to positive infinity, while the theta is this 0 to, what do you call, 2 pi. Okay. So let's substitute this integral there. So you're going to have I, say, you're going to have e to the minus r square by 2. Okay. Usually कर नहीं सकते वैसे directly sir, r, I can say I have r dr d theta dr doesn't matter, कोई फर्क नहीं पड़ता, किसी को भी पहले रख लें ऐसे d theta dr रख लें और ये 0 to 2 pi रख लें और r goes from 0 to infinity. ठीक है. So this does not depends on theta, so you can pull it out of integral. तो बाकी क्या बचेगा, 0 से 2 pi और d theta. So the integral of 0 to 2 pi d theta is going to be theta, और उस theta में जब आप limit substitute कर देंगे तो you're gonna get 2 pi r e to the minus r square by 2 dr. ठीक है. So if you wish you can put this 2 pi outside actually. ठीक है. So what you can do now, you can solve this integral easily. इतना कोई मुश्किल नहीं है solve करना. So if you do another substitution actually, ये देखिए यहाँ e के ऊपर r square by 2 है और यहाँ r मौजूद है. So if I do a substitution, say t equal to r square upon 2, ठीक है, तो dt is going to be really r dr. ठीक है. So just solve this integral by substitution. So you're gonna get 2 pi times e to the minus r square by 2. ठीक है. E to the यहाँ minus भी आएगी 0 to infinity. ठीक है जी. So 2 pi e to the minus infinity, substitute infinity, you're gonna have e to the minus infinity, और e to the minus infinity क्या है? So that kind of goes to 0, and so you have a 2 pi 0 minus, और अगर 0 substitute कर दें r की जगह, so you're gonna get minus e to the 0, so you're gonna get what we call plus 1. So the answer is pi. ठीक है. So what finally you get, so you get this I square equal to 2 pi. So what will be I if the I is going to be square root of 2? और I क्या थी? I is really your integral from minus infinity to infinity. ठीक है. E to the minus y square by 2 and dy, so it turns out to be equal to what is equal to 2 pi. So if you take this integral and substitute it in star actually, so in other words इस integral की जगह पर, so replace this integral by square root of 2 pi. So the square root of 2 pi will be cancelled by the square root of 2 pi and you're going to get equal to 1. And this is what you needed to, what do you call, show that this, the formula that you wrote, f of x equal to e to the x minus mu square by 2 sigma square and square root of 2 pi sigma is indeed a PDF actually. So that is what we have shown, that the integral from minus infinity to infinity e to the minus x minus mu by sigma का square divided by 2, ठीक है, and everything divided by square root of 2 pi sigma dx is equal to 1. This is indeed a PDF actually. ठीक है जी, this is indeed a PDF. Okay. Let's investigate some more properties of it. So आज we'll do the mathematics part, this dirty part actually, and then in next discussion we will do some examples and so on and so forth. Okay. Let's do. Let's compute the expectation of x. Let's compute the expectation of x. So in order to compute the expectation of x, what we need to do the integral of x e to the x minus mu by sigma chi square and everything divided by 2 over square root of 2 pi sigma and dx. This is what you're going to get. Okay? I can pull these numbers out. I can write this, say 1 over square root of 2 pi sigma, or maybe, just do the direct substitution, the same that we did previously. So let's substitute, say y equal to x minus mu by sigma, okay? Then as previously, what will be the changes in integral, so the limits are going to still be same, okay? This guy is going to be e to the minus y square by 2. Dx divided by sigma is going to be dy as previously. And what would be the value of x in the terms of the y? So if you substitute this here, so if you try to compute the value of x, so it's going to be sigma y, okay, plus mu. This is what it is going to be, sigma y plus mu. So you're going to have sigma y plus mu. Okay, this is what you're going to get. And if you simplify this integral, what you're going to get? You're going to get sigma minus infinity to infinity y e to the minus y square by 2 dy plus you're going to have mu times minus infinity to infinity. So it's like multiply e to the minus square by y square by 2 with this factor and this factor as well. So you're going to have e to the minus y square by 2 and dy. Okay, so you're going to get this, and please don't forget that you have this square root of 2 pi as well. So keep this square root of 2 pi here. Okay. What would be this guy? So this guy is really, what do you call, y e to the minus y square root by 2. So this is like what you get there. So if you're going to compute this integral, you're going to get minus e to the minus y square by 2. And then substitute the limit minus infinity to plus infinity. Plus mu times, what is this integral? So we previously just computed this integral, and this is equal to the square root of 2 pi. ठीक है? So let's substitute the limits. So the infinity will make this e to the minus infinity. So it is going to be 0. And then if you're going to substitute say minus infinity into it, so it's going to be still e to the minus infinity. So it's going to be 0 again. So the first term goes to 0. So what is going to remain? So 1 over square root of 2 pi multiplied by mu square root of 2 pi. So you're going to get 2 pi multiplied by square root of 2 pi. So everything is going to be equal to mu. So the mu is really the first parameter of normal distribution. So what we proved, we just proved that if x is normally distributed with parameters mu and sigma square, then expectation of x is this parameter mu. Okay, so we computed that expectation. Now let's compute the variance of x. But we know that the variance of x is expectation of x square minus expectation of x and everything else square. This is what the variance of x is. So expectation of x we already know it's mu. Let's compute the expectation of x square. So what would be the expectation of x square? So the expectation of x square is going to be e to the minus infinity to infinity x square and e to the minus x minus mu over sigma chi square by 2 and everything divided by 2 pi sigma and d. So this is what it is going to be. Okay? So how can we proceed? So we can do the same. Let's do the substitution. See, the same tricks works again and again. So let's do y to be what you call x minus mu by sigma. Then dy is going to be dx by sigma. And as x goes to infinity and the limits, as we know actually. So with this integral is going to be equal to minus infinity to infinity. X is going to be same as previous one, sigma y plus mu. So you have sigma y plus mu square. Okay. So you're going to get e to the minus y square by 2. And dy by sigma will, dx by sigma, this is dx. dx by sigma will become dy. And what remains also is this 1 over square root of 2 pi, so let's put it outside. So you get this neat integral in a much more simpler form. So let's simplify it even more. So what to do? Let's expand this square. So 1 over the square root of 2 pi minus infinity to infinity. Okay. Or maybe I can put this square root of 2 pi on the other side. Doesn't matter. So if I'll simplify it, the first term is going to be sigma square y square multiplied by e to the minus y square. So it's going to be sigma square y square e to the minus y square by 2 dy. So this will be the first integral. The second integral is going to be 2 times of sigma y mu. So it's going to be plus minus infinity to infinity 2 sigma mu y e to the minus y square by 2 dy. Okay. This is what is going to be the second term. So just simply twice it. And the last term is going to be plus integral from minus infinity to infinity mu square and e to the minus y square by 2 and dy. So So this is what it is going to be. Now let's simplify it a bit more. So what you're going to get? So 1 over the square root of 2 pi. The sigma square is a number, you can pull it out of integral. Minus infinity to infinity y square e to the minus y square over 2 dy. Okay. Plus this 2 sigma and mu, they are really like the constants. So 2 sigma and mu, they are like the constants. So you can pull them out of integrals. So what is going to remain is y e to the minus y square by 2. And what is the integral of y e to the minus y square by 2? So we have computed it previously also that this is going to be e to the minus y square by 2, and integral goes from minus infinity to infinity, and we know that this is 0. So substitute infinity, you're going to get e to the minus infinity, e to the minus infinity, so it's going to be 0. Plus, so you have this mu square, you get this mu square, and if you pull it out of integral, and what is remaining is minus infinity to infinity e to the minus y square by 2 dy, but we know that this integral is equal to square root of 2 pi. So things are very much really simplified. Okay. So if you simplify it a bit more, so you're going to get what? You're going to get 1 over the square root of 2 pi sigma square root by 2 pi, and this minus infinity to infinity y square e to the minus y square by 2 dy plus mu square. Okay. So this is what that you're going to get. So now let's come to this last part actually. So you have this y square multiplied by the exponential function, and you want to simplify this function. So what you can do? So you can apply your integration by parts formula, whatever integration by parts formula that you have learned. I mean, if you recall, what is your integration by parts formula? So there are different versions of it. So you might have learned this u dv from a to b. So it's going to be uv a to b minus v du a to b. So this is my favorite version of integration by parts formula. So you need to decide what should be your u and what should be your v actually. So let's take our u to be y square. So the du is going to be 2y dy. And let's take, say, okay, dv to be what? E to the minus y square by, no, shouldn't do like that, shouldn't do it like that, okay, no, we shouldn't do it. Let's take u to be y, so the du is going to be dy, yes. Let's take u to be y, so the du is going to be dy, and let's take, say, dv to be y times e to the minus y square by 2 du. Okay, let's take this to be dy. Okay, so I had y square e to the minus y square by 2 dy. So I picked one y, I called it u, and the rest, जो कि बाकी बचता है y e to the minus y square by 2y, I gave it a name dv. So what would be v then? So in order to compute v, you need to integrate this y e to the